At properties of exponents. So we've already been working with exponents. We've learned that exponents are undone by roots, and so we've gone through these things, but now we're going to see if we can figure out some of the rules that go along with it. So the first one we're going to look at is if you put this in your calculator, I want you to put both 3 to the power of 0 in your calculator and negative 3 to the power of 0. And obviously, if you didn't push pause, then you're just waiting for me, but I would love you to do it so you can see. When you put this in, you got 1, and when you put this in, you got negative 1. So if you can fill in what this is going to be, then fill that in. I'm just going to show you how it works, okay? So I'm just going to start with, let's say that we had 2 to the third power. We know that 2 to the third power, I gotta change this, I'm gonna actually do it over here so you can see. Let's say we had 2 to the third power. We know that 2 to the third power is 8, which means 2 to the second power is 4. 2 to the first power equals 2, and 2 to the 0th power equals 1. I'm gonna show you why this works. So when we had 2 to the third power, you'll notice that when we took 8, which was 8, 2 to the third power, which is 8, and we divided by 2, oh my, that's a divide, it equals 4. You'll then notice when we took 4 and divided that by 2, we got 2, which was 2 to the first power. So if I took this and divided it by 2 again, I would get 1, because 2 divided by 2 would give me 1. So it's either always going to equal one of two things. Anything to the power of 0 is going to equal one of two things, depending on if your base number is positive or negative. So, all right, our next one is anything to the power of 1. You will not always see a power of 1 because, again, 1s are so shy. They're invisible. They don't like to be seen. So even though this is 8, it could be written as 8 to the power of 1. Even though this is negative 5, it could be written as negative 5. Just don't forget that there is your invisible 1 there, even if you can't see it. So this one always equals our base number. These are the only two I'm going to show you, actually. And then you can put in, if you can figure out the pattern of the rest, you can say that what we did. All right, so I'm going to show you how this one works. So 4 squared would look like this, 4 times 4. And those of you who've done your assignment, you already did some expanding your exponents and you did condensing. So we're first going to expand this and then we're going to condense it. So 4 squared would be 4 times 4. And then we have our times here, so that's there. And then this says we have 3 more 4. So 4 times 4 times 4. So our rule would say instead of writing this out, so we've expanded it, so we've written an expanded form. Well, instead of doing that, I would realize that I have 4 times 4 times 4 times 4 times 4. I could rewrite this in the most simplified form as 4 to the 5th power. So you'll notice I had my base, which was 4 in both cases, and then I ended up with a power of 5. So let's see on this one what happens. M to the third, and I used variables because some of you guys just put this in your calculator. It will not give you a power. Sorry, it's kind of hard to see. It will not give you the power. It'll give you your final answer because it will tell you what 4 to the 5th is. So if it says write it using the product rule, we know this is product because product means times. That's what product means. And so we're multiplying two things together with powers. And we're going to be working with same bases. So on this one, I have m times m times m times, and even though, again, I can't see it, this is an invisible 1. So I still have an m here. So you'll notice I expanded it, and now I have m to the 1, 2, 3, 4th power. So if you can figure out what the rule is here, write it down. And I'll check it if you want, but I'm not going to give you the rule. You're going to have to write it out like this until you can figure out what the rule is. So now we'll notice that our next one is power to a power. You can see there are parentheses involved in these, which indicate, hopefully you remember, multiplication. So we're going to do this a couple times. So inside my parenthesis, I have 4 squared. So I'm going to write 4 times 4. That is what is inside my parenthesis. This tells me how many times to repeat it. So I have it once, I have it twice, I have it 3 times. So again, I have 4 times 4. There's a times here. There's a times here. So 4 times 4 times 4 times 4 times 4 times 4. This gives me 4 to the 1, 2, 3, 4, 5, 6th power. Again, what did you notice about that? This one says inside my parentheses, I have y to the 4th power, which would be 1, 2, 3, 4. Y to the 4th power. I've expanded that, but I need that 2 times. So this tells me how many times I need it. So I have times 1, 2, 3, 4. So again, I would end up with y, because I have only y's here. 1, 2, 3, 4, 5, 6, 7, 8 to the 8th. If you can figure out the rule, use your rule to use your words to fill those rules in. A power of a product. You will notice there are still parentheses here. We still are going to be doing something with multiplication. So again, I'm going to take and expand what's inside my parenthesis. So expanding this, I would have 1, 3, and then I would have 3 a's, a times a, and b, because this would be b to the 1st power. And I need that 2 times. So there's 1 time, and I'm going to expand it again. And then I'm going to look, and I'm going to write it in exponent form. So 3 times 3 would be the same as 3 to the 2nd, or you could put it as 9. That would also work. But that would be 9, and that's what I'm going to do because I know what 3 times 3 is. Now these ones I don't know here. I don't know what a represents, but I know that I'm going to have a to the 1st, 2nd, 3rd, 4th, 5th, 6th power. And then I'm going to have b to the 2nd power. Is there something you notice happening with the outside number and then on the inside? Again, we have our next one. This says take what's in our parenthesis and expand it. So I have a 4, and then I have 2 m's, so times m, and then I have 2 b's times b times b. And I need that 2 times. So I'm going to times that by another 4, another 2 m's, and another 2 b's. So then I would have 4 squared, which I know is 16. And then I have m to the power of 1, 2, 3, 4 to the 4th power, and b to the 1, 2, 3, 4 power as well. Do you see a pattern there? Remember that even though this 4 doesn't have an exponent, it's that invisible 1 that's shy, just like this b had that invisible 1 that was shy on this one here. Not this one. This one you can see the exponent. Okay, so that's, see if you can figure out the rule for these. I will check these rules if you would like so that you can, we can look to see if they're correct. The last rule we're going to deal with is quotient. So this says take on the top of my quotient, which is division. So quotient means that we're dividing. This says take what's on top and expand it. So this means that on the top here, I'm going to have 1, 2, 3, 4, 5. 5 4s. On the bottom, I'm going to have 1, 2, 3. Now, you should know that anytime, and you notice it's only multiplication on top. I don't have any addition, any subtraction. It's only multiplication. So I can start canceling things out. If I have something on top that's also on bottom, I can cancel it out. I'm going to use red here. So I'm going to cancel out this. This becomes 1. I still have a 4 on top and a 4 on bottom. This becomes 1. I still have a 4 on top and a 4 on bottom. This becomes 1. I have nothing else left on bottom. So on the bottom, I have 1 times 1 times 1, which is 1. And then on the top, I have 4 times 4. So I could say that I should have made my equal sign over here a little bit more, but this is 4 to the 2nd power. And you could put it over 1, but really it would just be 4 to the 2nd power because I'm left with 4 times 4 on top. So now let's look at this one. Again, you're looking to see if you can figure out what the actual rule would be here. So on this one, it says on top I have 6 ends. So I have, let me use a different color. I have 1, 2, 3, 4, 5, 6 ends, and I'm timesing that by 2 m's. So I have the top written out. And then down here I have 2 ends and 1 m. So I start looking to what can cancel to 1. Well, I have an n on top and an n on bottom. That comes a 1. I still have an n on top and an n on bottom. That becomes a 1. I have more n's on top, but I don't have any on bottom, so they can't cancel. But I do have an m on top and an m on bottom, so that becomes 1. Those two together would become 1. So when I'm done, I would still have 1, 2, 3, 4 n's, so I'd still have n to the 4th on top times m, because this is still here, and you can put a time sign there if you want. And then on the bottom, all of those canceled to 1, so I would just have a 1 on bottom. Or rewritten, I could say n to the 4th m. That kind of looks like a 4 in between there. Let me do that again. N to the 4th power times m, and be done. Did you notice what was happening to my exponents? I started with 6 here and 2 on the bottom, and I ended with 4. I started with 2 here, and again, it's invisible, but there's a 1 there. See if you can come up with those rules.